Okay now? Okay. If it changes, let me know. My name is Alfie Fresta. It's great to be here. It's my first time at FOSDEM. I'm here to talk about credentials for Linux and the efforts to bring passkeys and other credentials to the Linux desktop. Before we start, do a show of hands. Who here has ever used a passkey? Most people, as you expect here. Who here feels that they have a good grasp of what happens from the moment you tap a security key or use your passkey onwards? Like what happens behind the scenes? Yeah, the passkeys are quite complex. We're not as intuitive as passwords. I'll briefly talk about them before we start. So passkeys are public key credentials. They are designed to replace passwords and multi-factor authentication. In fact, a passkey is in itself two factors. You need both your device and either biometrics or a PIN normally to use a passkey. Passkeys are built on two main specifications. W3C's WebAuthn, which I guess is short for Web Authentication, defining the APIs for apps and websites to use, and FIDO's CTAP, which stands for Client to Authenticator Protocol, for what happens behind the scenes all the way to the actual hardware. A bit of history. Passkeys are a subset of FIDO2, which is a successor of U2F, or Universal Second Factor. There's a lot of acronyms. This was a protocol originally intended for legacy or older security keys. I have a massive collection of them there. So there's like USB keys, there's you can use NFC cards, you can see Bluetooth connected buttons as authenticators. FIDO2 introduces passwordless credentials, meaning that you no longer need a first factor. But passkeys actually raise the bar over FIDO2 one step further. They're specifically so-called discoverable credentials, which generally means that the credential itself resides at rest on the authenticator hardware. And crucially, this means they can be used in a usernameless fashion, meaning that the passkey is your username, your password, and your second factor all in one. So yeah, this is like USB type, so it has a biometrics that you need to use. So by touching it, you prove possession of your security key, and as well as who you are. In terms of flaws, of UX flaws, FIDO2 adds two important ones. One is hybrid, which enables using your phone as a roaming authenticator, is what the spec calls it, I believe. So it's using a passkey on your phone on another device. Like normally it's intended for the first use scenario when you activate a new device for the first time, as well as synced credentials. So this is effectively storing passkey in your Google account or your password manager, which syncs them across devices. If you want to learn more, there's I've linked in the slides a great talk, which it's from a few days ago, entertaining podcast on why the things are as complicated as they are now. It's a great watch. I want to highlight that security keys matter, but for mass adoption, it's phones and password manager that will define the passkey landscape, in my opinion. There's why passkeys became so mainstream, and virtually everyone nowadays owns a phone that's capable of being an authenticator. So Linux needs to treat smartphone flows and password manager as first-class citizens. I've already stressed that third-party credential providers are very important for the ecosystem, but it's even clearer if I say that they're now actually the default. On most Android and iOS devices with Google Password Manager and iCloud Keychain, I think it's a passwords app, it's what it's called, they're on by default. And both platforms still allow you to choose your own favorite password manager as an alternative. Both as source of passkeys and to manage syncing those passkeys to other devices. This is important because it requires that the platform provides secure APIs that interface the platform with the password managers as well. So why are we here and what problems do we try to solve with credentials for Linux? First, the Linux desktop needs platform APIs. So these are what the browser or the app interacts with when accessing passkeys. On Windows, iOS, macOS, and Android, browsers and apps do this. They call into the OS to use a passkey. This is kind of what it looks like on latest platforms. Second, we don't have platform APIs on Linux, but browsers and apps still need access. So, which means that what they do is apps that use passkeys currently must implement every bit of the CTAP protocol themselves, and generally directly access hardware themselves. This could be directly accessing the USB stack or the BLE stack, the Bluetooth stack. And so as you expect, the UX is also quite inconsistent between apps. On the left, you can see Firefox. It's falling back to its own client implementation. It only supports USB on Linux right now, as far as I know. No Bluetooth, nor can you use your phone as a passkey. On the right, you can see Chromium on the other hand, which in itself, I believe, is one of the best implementations that you have in terms of UX, but it looks very different from Firefox. And they've also recently removed functionality. You no longer can use, for some reason, Bluetooth keys, standalone Bluetooth keys. They've removed them after they were previously supported. And also, if you use a QR code from your phone, remember this device is no longer an option. I also want to call out containerized apps. So without any passkeys APIs that these apps can use, they have no access to authenticator hardware by default. So if you're using a browser as a flatpak, for example, unless you have an extension for your password manager in that browser, your only option is to provide the browser with direct access to hardware, which can be much wider than what you actually want, effectively breaking the sandboxing. And it will, in all cases, create a risk for origin bypass. And let me give you an example. Let's imagine a hypothetical malicious FOSDEM app. It will tell you, I want to log you in on FOSDEM.org. Please tap to use your passkey. But secretly, what it's telling you that it's authenticating you on FOSDEM.org, it's sending a request to your security key for google.com. And so this has no display. It has a blinking light. You tap it, and you just you authenticate on your behalf to Google, and it starts reading your email. Clearly not ideal. I'll talk about the idea now and what we built so far. So what we want is, for example, a browser or some other Flatpak app here on the left. We want them to be able to access credentials. Right now, we'll talk about passkeys or whatever, on whatever device. And they're there on the right. And so they need to be able to do that just by calling this new credentials API. We want the service to handle everything, talking to devices, these CTAP protocols, asking the user for permission, showing that UI, and also choosing which passkey or which device. So here's what we built. We have this new two components to power this new credential API. Together, this is what currently makes up credentials for Linux. libwebauthn is a platform library, and this implements the FIDO protocols and the transport to authenticators. And credentials-D for the interfaces with applications and credential providers. I'll talk about credentials-D first, because this is the component that most of you will be interested in as Linux developers. And this includes the Linux credentials API, which will be available over dbus, used by containerized apps and browsers alike. And the credentials provider API, so you can plug in your own password manager. I'll demo this at the end. I'll show you a video, but I also invite you to try it out for yourself. Check out the README as instructions. Keeping in mind the UI right now that you see is currently a reference implementation. It's only meant to be an inspiration for desktop environment developers who actually know what they're doing with the UI, not like us. So this wink wink if there's any GNOME or KDE developers in the room. I love to chat. Credentials-D is split into two. It has the front end, which processes requests, talks to apps, devices, and credential providers. And it has the back end, which is native to each desktop environment and shows the user prompts. This naming and this pattern is the portal pattern. I guess, let me ask a question, like, who here is familiar with XDG desktop portals? Okay, there's a few. So I'll be brief, like portals or XDG desktop portals, they're APIs for sandboxed apps, such as Flatpaks, so that they can safely access functionality outside of their sandbox. There's a lot of them, and they provide different functionality. They've also become increasingly platform APIs for desktop apps, not necessarily the sandbox ones, to access functionality because it's more convenient at times, and they're exposed via dbus. As for where we are right now, XDG desktop portal, developers, they are on board with a plan, and we're working alongside them. We'll make credentials the de facto implementation of a new credentials portal that will be added to it. We have a prototype portal with a specification you can check out. We're discussing the finer details in the work in progress PR that I've linked if you're interested, if you get the slides. On the other side of the project, we have libwebauthn. So this is Linux native. It's a Rust implementation of the FIDO specifications. It supports both FIDO2 and the older U2F for second factor. It has a pluggable transport interface, which just means that it's easier to add new transports like Bluetooth or NFC without having to implement the protocol. It's taken a while. I personally started working on this in 2020 before Passkeys because I was frustrated that Firefox at the time only supported USB keys. However, thanks to a lot of work from a few key contributors, it's now quite fully featured. Sorry. So there's two dimensions. One is transports, which is shown here. And I'm proud to say we support all transports now to external authenticators. This is USB, Bluetooth Low Energy if you have a Bluetooth authenticator. The one Google no longer supports. NFC if you want to tap your security key. You can use there's some keys that you tap to your phone, and you can actually use cards with card readers as well. And hybrid, which is the flow where you use your phone to scan a QR code, and you can remember the pairing as well. We support that. I'll go through like an example in this diagram to like kind of try and explain how this fits together. So let's say you have the FOSDEM app, and it's going to be at the top, and this app requests to use a passkey for FOSDEM.com, FOSDEM.org. Sorry. So you do this the same way that you'll access any other portal. You make a request via dbus to XDG desktop portal for the credentials portal API. The portal proxy then routes this to credentials D, specifically the front end, which checks the requests, validates it, and identifies any possible credential sources for this request. It may talk to password managers at this stage to understand if they have a credential, and also identify which devices are available on the system. It will then call into the UI backend, say GNOME's portal implementation in this case, and it will show a prompt native to GNOME, which is not our one. That one is our reference UI. But it will identify the app, saying this request comes from the FOSDEM binary. It will say this is for FOSDEM.org, and it will then allow the user to choose their device. It might have multiple passkeys, and you'll be able to select that. And I say the user, in this case, chooses to use their phone. The request then credentials routes this to libwebauthn, which generates a QR code. Your laptop will actually start listening for a Bluetooth advert. There's a proximity check built into passkeys like this. libwebauthn will then listen for that signal via Bluetooth, and it will detect the QR code scan, and it will negotiate an encrypted tunnel directly through the internet from your laptop to the device. And we'll retrieve the credential, and finally this goes back to the browser at the top. I want to mention a few open challenges because we've not solved all the problems. Origin scoping is the first one. This is a guarantee offered by WebAuthn. It can be written as follows. Credentials for your origin, so in this case, say, FOSDEM.org, should only be accessed by your origin, so your website, or authorized related origins, if you have a website that uses multiple domains, or authorized native apps. On Linux, if we get a request from the FOSDEM library from the FOSDEM binary, how do we determine which origins we should have access to? Challenge 2 is an extension of the one. Before we can even think of associating allowed origins to an app, how do I verify for certain that the app is what it says it is? On Android and iOS, this is achieved cryptographically by using the signing keys of the app or the developer certificate. On Linux, how do we achieve this? And if you have any ideas, please come contribute to the debate. Join the Matrix room. I'll share at the end. So the goal is to do the same as other platforms. There are two types of apps. One is mainly browsers. These are special. They have a genuine need to access credentials for any origin. And these are privileged clients. And then all other apps. Going back to our example, the FOSDEM app only needs access to fosdem.org, not google.com. On other platforms, you have these two different APIs and specific access control. For example, on Android, if you want to get access to the privileged API, you have to declare your app as a browser and get some special permissions, I believe from Google, through Google Play. So the current state right now in the implementation, there's a single API, but every request is mediated by the user. So if the user is using Firefox, they will get a prompt that says the Firefox binary wants to access a credential for this specific origin. So right now we're delegating the problem where the user has to solve that problem, the user has to decide whether that application should be accessing that credential. What's next? What it's doing right now, it feels we're generally close. We do have a few gaps to bridge. The highest priority is probably upstream integration. We need patches and collaboration from browsers. We have a patch for Firefox, which I'll demo, but we do need help from other browsers. So if you're a browser developer also, let's chat. And then storage for remembering devices. So if you scan a QR code, you don't have to scan a QR code every time. Third-party providers, passwords and OTPs, so other types of credentials. These may include verifiable credentials in the future, so the W3C API that can be used for digital IDs or provide proof of age. I say that because there is a lot of common infrastructure in the specifications, in the technical implementation. So the QR code flow is also shared with but without digital ID flow. Finally, FIDO specs are evolving, and we're going to make sure to keep up. Do I have a demo now? Hopefully that works. I'll show first the QR code flow. So this is one of the latest Firefox builds, although it's not the latest credentials D build, so the UI has changed slightly. So what I'm going to try and do is just sign in the GitHub. I'm going to use signing with a passkey, and this is now calling into the portal API. I've selected I want to use my phone. What I do is I use my phone to scan a QR code. If I were to do this, my phone will ask me, do you want to use a passkey? I tap on it and say yes. And then I select the passkey and use my biometrics, and that's it, device connected. I think at this point I'm doing biometric on my phone, and I'm logged in. So I used my phone without having ever previously connected it to my laptop. This is the USB flow, which is very similar. Again, I click connect, security key. I'm using a biometric one in this example, so I just scan my fingerprint, and I'm logged in. It's really that fast. Please get involved. There's a lot to do. If any of this is interesting to you, if you'd like to help, we'd love to chat. You can find us all on Matrix on that address. We're a friendly bunch. Don't be shy. And that's our GitHub as well. I wanted to call out some projects that have been helpful or could be helpful for future expansions, but in the interest of time, I think I'll leave them here. Before we move on to questions, I just want to thank two core contributors who have spent lots of time over the past few years in the project. Isaiah, he started a while back leading the portals and provider integration. He is now funded by WebAuthn, which is awesome. And Martin Siringaus, he should have been here with me today. Unfortunately, was not able to make it from SUSE. He's put in a massive amount of work recently and contributed his expertise from working on Mozilla's authentication library in the past. So thank you very much. And yeah, any questions?
Please repeat the question.
Okay.
In Credential D, are you supporting already like also the enrollment of the passkey? Because when you use the user verification, you actually need to enroll.
Yes. So that's sorry, repeat the question. Yes. So the question is, on Credentials D, do we currently already support enrolling? I'm assuming it's enrolling the biometrics for a passkey. So if it's the first time you use, for example, a USB key which has biometrics, the user actually has to register their fingerprint, and this is part of the setup protocol implemented in actually libwebauthn, and the UI and the flow is provided by Credentials D. That's already supported. So that's both for setting your PIN the first time you set up a security key, as well as enrolling biometrics, which means scanning your finger a few times until the security key is happy that your fingerprint is scanned.
Include this in the settings apps or
I believe so. The question is, do we plan on including this in the settings app? I do believe so. I will encourage you to ask that question in the Medic channel, because I think Isaiah will be the best person to answer that question. I also know that I think it's most common for users to go through that flow as they use their passkey. So as they try and create a passkey or they try and use a passkey, the UI will prompt you to do that on the first use. But there should be some management on the settings page, also to add and remove password managers. So you can set them up from there.
So, another one?
This is a great question. So the question is timeline. This is a timeline for this to be upstreamed to Firefox. So we have a patch up for review by Firefox. I'm not sure there is a specific timeline. If you know any Mozilla developers, maybe we can ask them. I think that Isaiah's goal, I believe, I don't know if I'm supposed to mention this, but it's for that to hopefully go in the next Fedora release, if we can. But I think it's also up to upstream, whether we can get those patches up and whether we can get that Chromium patch as well, which we don't have right now.
Yes, and we have another question. Yeah, we have time.
So my question is, this all works after you have a user session, so you log into the system. What about the pre-login situation?
Yeah. So the question is, this all works once you have a user session. What about pre-login? I think that's a great question. I think different systems take different approaches. I believe Windows and Law is kind of a single system which is able to do both sign-in as well as manage credentials for applications. Right now, we're targeting applications. I believe there's actually another talk about GDM and Passkeys, which I'm here to listen to.
The question is, can we integrate this work in pre-login situation? What might prevent it?
I think what might prevent that if we want to integrate this work in pre-login. I think a few challenges is, for example, when you're using a passkey, we have store devices. For example, you might already use your phone, and we might link to your phone. So if you're not logged in, for example, you might not be able to use that link, because that's presumably we can only access that information after we identify the user. But other than that, I don't know if there's much. There's the problem of which origin do you use, like which app is making the request. WebAuthn works with the domain, so you might have to make one up. It's an interesting question. I think other people in the Matrix channel also might have a better answer than me.
So, more questions? Anyone? Yeah?
If you clearly present the URL you're going to in the choosing passkey screen, do you really need two different levels of permissions for browsers and others?
So the question is, if I present the full URL or the origin of the requesting of the application of the passkey in the user prompt that I'm displaying to the user, do I really need different permissions for applications? For browsers and normal applications. So do I really need a privileged and an unprivileged API? That's a good question, and I think the answer we're going for is not strictly, because we're not going to be able to do that for launch or for our first release. We don't currently have a solution to those questions that we need so that we can create an unprivileged API. I think I believe it will be the first platform to launch without an unprivileged API. And so I do suspect this has some risk in that all other platforms that I know about, Android, macOS, Windows, do have that access as far as I know. I do believe there's a security trade-off because users may, the request may be intercepted, users may not necessarily know. I think it's, yeah, I don't believe it's strictly necessary, I guess, but there's some trade-off.
Okay, so thank you.
Thank you.